For today's episode, we're going to do one part of the upcoming trial exam punya practice. Now, I highly recommend you guys to download this in the description below. Take out your iPad, take out your paper, let's do this together. Now, for the first one, I'm going to introduce you this concept of what is a threshold frequency. So similarly to what we have learned before in electronics, so there's something called thermionic emission. So what's thermionic emission? When you take a fire and then you give this metal a bit of heat, then your electrons will be emitted. So this process is known as a thermionic emission. So thermionic emission, why? Because got temperature, got ionic, then this is called thermionic emission. However, for today's stuff, it's going to be light. So we shine light on the metal. Metal has free moving electrons. So these electrons will be emitted. So this is actually known as what we call the photoelectric effect. Now, to be more specific, in textbook, they don't usually call this electron only, but they also call this sebagai, what they call it as photoelectron. Now, why do we need to write the photo? Is because the electron is emitted due to the light. So that's why they call this the photoelectron. But is photoelectron and electron the same? Yes, they are actually the same. Okay, just we need to introduce the word photo, keyword. Okay. Now, so in order for photoelectron to come in, there is a rule that says that the energy of the light that masuk must be stronger than something baru your electron can be emitted. Okay, so what is this something? So there are two things. One, we can call this as the work function. So this will be measured in terms of joules. So if you want to compare energy, you will take the energy of the light, joule of the light, compare versus the work function. So the photon energy, the light energy has to be larger than the work function. Or the other one is the one that I want to talk about here, is this thing called threshold frequency, which is measured in terms of hertz. So if exam give you joule, you compare versus joule lah. But if the light give you is frequency, is it in hertz, then you compare versus hertz lah. Joule compare joule, hertz compare hertz. So threshold frequency. So here they ask you, what is the minimum frequency that allows the electron to be emitted? So therefore, this is the term that we wrote just now, whereby we talk about this is your threshold frequency. The keyword that we're looking for here is the word minimum frequency. So if this one become minimum energy that allows the photoelectrons to be emitted, then this will be our work function if it is minimum energy. Okay, so this is the definition for your threshold frequency. Better to write here, allows what? Photoelectrons, so that your teacher cannot say you never write the proper term. Okay, next. So what will happen to the kinetic energy of the electron when light intensity increases? So in this short video, I'm just going to show you one simple example of formula, okay, half mv squared. Now, which I can summarize into two things. Number one, okay, frequency. If your frequency increases, so this HF is actually what? Your photon energy. If you don't know what is photon, that is your light energy. So when your frequency increases, based on this equation, your kinetic energy will also increase. So kalau frequency increase, your kinetic energy will increase. What will affect your frequency? So color will affect your frequency. Wavelength will affect your frequency. So if the exam asks change in frequency, change in color, change in wavelength, this will all affect the kinetic energy. But then now they're asking you intensity of light. So what is intensity of light? Intensity of light is actually calculating how many biji of photons is being emitted. So it's a total different thing. So that's why here, if you look at this equation, totally tada intensity of light. So therefore, my kinetic energy will be unchanged. Okay, quiz. So if I increase intensity of light, what will be affected? Intensity of light will only affect the number of photoelectrons emitted. So guys, remember, intensity of light is actually the number of photons. Got how many light? So that will affect how many electrons. How many photon, how many electron. But your frequency will increase your energy, then your kinetic energy will change. Okay, Ken? Alright, so you have to make sure you understand this part first. Okay, so answer your explanation. Because we will say that the intensity of light will increase the number of photoelectrons emitted. Okay, it will increase the number of photoelectrons emitted. So therefore, not the kinetic energy. Okay, so guys, for this video, we'll just write shortcut then you write yourself. Okay, so kinetic energy will only be affected by the frequency of the wavelength or the wavelength, okay, of the color. Okay, now we got one question. This one is the considered difficult already. All right, so they give you a graph. Okay, to make this simple, I'm going to summarize that this graph is actually berdasarkan just now our equation HF minus W equals to half mv squared. So HF minus W equals to half mv squared. So this is your kinetic energy. So if you see this Kmax, Kmax is actually your kinetic energy. So therefore, this is actually your y-axis. This is equals to mx plus c. Okay, so my gradient is my Planck constant. My y-axis is my kinetic energy. Then c is my what? My y-intercept. That is my negative work function. Okay, I hope you can understand this part. So this thing will go all the way down here, all the way sampai here. This is your y-intercept. That will be your negative work function. Okay, so negative work function is what? It's your minimum energy to throw electron. Okay, we check back. It's the minimum how much energy you need to throw electron. Let's say my light energy come in is 50 joule. Let's say my work function 10 joule. So if I have more than the work function, what's the light stronger? Stronger than the work function. So my electrons will be emitted. Okay? So that is your work function. But at the same time, if you take the x-intercept, this will be known as your threshold frequency. So this will be the minimum frequency needed to throw electron out, photoelectron. So let's say my minimum frequency is 200 hertz, Then how much frequency minimum, how much energy minimum that my light needs to come in? So the answer will be 200 lor. So when my light come in with 201 hertz, this is 200, this is 201 hertz. So will you have electron? Yes, because the light frequency higher than your threshold frequency. Okay. So now you have to know these two things. Okay, that's the threshold frequency and that. So what is the meaning of threshold frequency? So this is the minimum frequency needed for you to release what? Okay, photoelectrons from the what? Remember, the most important word here is metal surface. Alright, if you want to have more specific, you can refer back to here. So minimum frequency that allows or that needs and so on. Compare frequency of A and B. Okay guys, if they give you this comparison to do, this will be the easiest question that you're going to ever see. Why? Because A is here, B is here. So guys, if you go towards the x-axis, of course, B is higher than A, right? So we'll just say that the frequency of light in B, or you can say of B, is higher than A. Okay, the frequency of light of B is higher than A because B, the right-hand side, right? Okay, can. Now, what about the kinetic energy? So for this graph, all you have to know is if you know the y-axis is the half mv squared, the kinetic energy. So now you compare A punya point, B punya point. A is 0.27 kinetic energy. B is 0.6 kinetic energy. So which one actually produces more kinetic energy? So obviously it's B lah. So you can see the maximum kinetic energy of the photoelectron emitted when of B is higher than A. So berdasarkan just now what I've told you, based on this equation, HF minus W equals to half mv squared, kan? So the higher the frequency, obviously the higher your kinetic energy is lah. So you can see here, the first one, we are comparing frequency. Number two, we are comparing the maximum kinetic energy. Okay, next, relate the frequency and the maximum kinetic energy of the photoelectron emitted. So here, how we usually relate is, we will say, the higher the frequency, then what's next? We'll say the higher the kinetic energy of the photoelectrons emitted, done. Okay, so the higher the frequency, the higher the maximum kinetic energy. Alright, so if your trial is going to happen very soon, at least you learn this, you can answer some questions. Alright? Okay, this is where this calculation requires you to be a bit professional first. Alright? But let's try to understand this thing. Okay, Ken? Now, so okay, we're gonna copy this graph. We're gonna copy this graph, and I'm gonna paste it here first. Okay, paste this image here. So let's see what we can do. Okay, what is the threshold frequency? Okay, guys, listen. Okay. So your work function and your threshold frequency is like abang adik. Okay, cuma one is measured in joules, the other one is measured in hertz. Abang adik. Alright. So usually we can write E equals to HF, whereby this E is your joule energy, right? So your frequency is hertz, right? So if you see joule and hertz, their relationship is related by a single alphabet known as H, which is your Planck constant. So your energy here, boleh juga if you want to, you can write this as your work function W, H is your Planck constant, F is your threshold frequency. You can relate them. So your joule is equals to Planck constant times the frequency. Joule equals to Planck constant times your frequency. So if you got hertz, you multiply H. If you got hertz, you multiply H, you get joule. If you got joule, you divide by H, you get frequency. Okay? So let's write this back here. I'm trying to find the threshold frequency. Do I have the work function? Got. Work function is 3 eV. Okay, when they give you this 3 EV, biasa niya guys, okay, they'll give you a few informations. So this information you can get from the front of your formula sheet. So if you refer to the front of the formula sheet, you have all this information. And then after that, they might even give you 1 EV is actually equivalent to 1.6 times 10 to the power of negative 19 joule. Okay, I know what you guys are thinking. Teacher, state paper will come up so difficult one, man. This you are doing right now is actually a Sarawak state paper, but 2 years ago. So, boleh keluar punya, okay? So let's change this work function to joules first, because EV is something we are not used to. So 1 EV is this much of joule. So we will take 3 EV multiplied by 1.6 times 10 to the power of negative 19. So I got 4.8 times 10 to the power of negative 19 joule. That is my energy, my work function in terms of joule. Alright. So okay, so I can write this down first. 4.8 times 10 to the power of negative 19 to be equals to my Planck constant here is 6.63 times 10 to the power of negative 34. I will get my work function to be this measured in terms of hertz. Alright, okay. So I highly recommend everybody to just probably try to tekan this into your calculator and see what do you get. Alright. So I've already calculated this thing already. So maybe you try yourself first. Okay, Ken? Okay, now, so what about the energy of light B when it is irradiated on the calcium metal? Okay, so very simple. So we have HF minus work function is equals to kinetic energy. So that is our general formula. Okay, we want to find the energy of light. So this is the one that we're trying to look for. So okay, I'm just gonna substitute this as B. Now the work function sudah ada. We already calculated our work function 4.8 times 10 to the power of negative 19. Okay, masalah sekarang is, do we have the kinetic energy? Yes, we actually have the kinetic energy, because for B, our kinetic energy is 0.6 EV. Now, if you ask me, gut feeling, guys, I think they will give you EV so complicated. They'll just give you this one mungkin already in joules. But if they give you an EV, it's just an additional step only, guys. You just have to take this 0.6 EV. What you're gonna do is you take the 0.6, you're gonna multiply by 1.6 times 10 to the power of negative 19. So what you're gonna do here is you're going to change this all the way to become joules first. Okay? So once you have this thing already, okay, let's just write this up together. 0.6 times 1.6 times 10 to the power of negative 19. So I just have to shift everything over, add together, I will get my photon energy of B in terms of joules. So it is actually not that difficult. What happens to the maximum kinetic energy if the intensity of light is increased? So just now what do we say? Will your number of light come out, brightness, affect your kinetic energy? No, because your kinetic energy is only affected by what? Your frequency, your energy, your wavelength, and your color. Frequency, wavelength, energy, color. So therefore here the answer will be, it will be unaffected. change. So therefore, that's it for our concept on what is work function and threshold frequency. Summarized version okay. For our second question, okay, we're gonna talk about this thing on current, whether in series or parallel. Now, if most of you see this question before, this is actually our Selangor punya state paper, but the 2023 version. Alright. Okay, so let's look at this circuit first. Very tricky one. Okay, so the first question here, they're asking you for what's the physical quantity measured by the ammeter? Now, common mistake, a lot of people will write ampere. Now remember, ampere is the unit, guys. Ampere is the unit. Okay, I actually stands for what? The symbol. So don't write ampere, don't write I, because they are looking at the physical quantity. So your answer here is actually current. But give you extra pointer. Some teachers, right, they see current, they're not happy one. So what they want is, you have to tell me what kind of current, water current lah, air current lah. So the answer here is, it is electric current. If you write this, your friend will be so surprised. Wow, yeah, then your teacher will give you correct, then maybe mark up the paper wrong. Okay, so the answer is electric current. Okay, now, which one will give you a higher reading of ammeter? Okay, so berdasarkan what we know, V equals to IR. The higher the resistance, the lower the current, if your voltage remains the same. Okay, if your voltage here remains the same. Now, I don't know if you do this or not, but people who know me knows that I have a very weird, how to say, style, where I like to draw my picture into a better picture that I can understand. Okay, for example, now I realize that this D is actually series to the ABC. So bermaksud that my circuit is actually this light bulb D is going to be separated into the light bulb A, okay, which this is your ammeter. I write ammeter AM1, because if I write A also, you will get confused between light bulb A and ammeter. And then after that, here I put B, here I put C, then I put AM2, ammeter 2. Okay, so this is how my circuit actually looks like. Alright, yeah, this is actually how my circuit looks like, because my D will then split into two road, then they will sambung balik sebelum they go back. So this is how my circuit actually looks like if you are curious. Alright, okay, if you are curious, this is how my circuit actually looks like. So where will be my battery? Okay, I didn't draw, but you can imagine that my battery will somewhere be above like this. So they are actually the same diagram. Okay, now we see. Here, atas, you only pass through one light bulb. Here, you will pass through two light bulbs. Guys, guess which side will have more current flow? Okay, because parallel, kalau parallel, the voltage here and the voltage here will be the same. So whichever side that has more resistance will have lesser current, less resistance will have more current. That's why here, if you do ratio, very dangerous. Okay, so which one has a larger reading? Obviously, the answer is ammeter 1, which is the L punya ammeter. So here will be the ammeter L. Okay, why? And what we can say here is because the effective resistance across, we can say the effective resistance, because the resistance over here, effective means that the current that flow on, the effective resistance is lower. The bottom punya effective resistance is higher because you have to add the B and the C. So you need to know how to use the word effective resistance. Effective resistance actually means your total resistance. It's lebih kurang the same thing. Okay, next. They say each part in diagram 4.1 has a resistance of 3 ohm. Calculate the current flowing through bulb D when the switch is turned on. Okay, let's have a look here. Now, according to my diagram, now if you try to look at the top part of the picture, it gets very confusing. But if you do my diagram, you will realize that this is actually very easy. Okay, why? Because this is 3 ohm, this is 3 ohm, this is 3 ohm, and this is 3 ohm. So usually, we will join those the smaller part first. Okay, you see, if I have a 3 ohm here, the outside one, whatever calculation we do, we'll do the inside one first. So the BC is the inside one. So I actually combine the BC so that my A alone sini is 3 ohms. This is the donkey. And then you will realize that my BC, because they are in series, I can straight away make them to become the 6 ohm here. Means I combine this BC first. So therefore, the bottom part will be 6, the top part is 3, then this side is 3. So next, I'll do the total resistance calculation first. So I'll calculate the parallel one first. So what we're gonna do here is we'll use the calculation 1 over R, 1 over 3 plus 1 over 6. So I will get 3 over 6. So R will be 2 ohms. So so this part is actually equivalent to 2 ohm. If I add the 3 and 6 together, then after that I will add back this 3 ohm together. So my total resistance here is actually 5 ohm. My total effective resistance of the whole entire thing is 5 ohm. So now I'll do V equals to IR. So when you do calculation, if you don't know where to start, if you are given all the resistance, always count the resistance first. Most of the question, maybe 8 out of 10 question will start with resistance calculation, so you don't worry about it. Okay, then they give you the battery 6 volt. So kalau they tell you that the battery is 6 volt, total resistance is 5. So now my current here will be equivalent to 1.2 ampere. So it will become 1.2 ampere. Okay, so it's a 3 marks calculation. So why? Because they want you to calculate your total effective resistance first. I think most of the people here will have a bit of problem on this part of the picture. Alright. Now if your problem is on how to see this resistance, maybe you can drop me a comment, and if let's say there's a lot of people who say that okay, resistance calculation headache, maybe I'll do a few shorts on how to calculate resistance. Alright. Okay, next. So finally we're gonna talk about what is the potential difference across PQ. So PQ is actually selepas the donkey and all the way to the end. So PQ is actually from here all the way here. So this is P, this is Q. PQ, if I write here, is actually from the start after your donkey here all the way to Q. Okay, then I copy down again. So this is P, this is Q. Alright. Now I know that PQ sekarang is actually across a resistance of 2 ohms. The PQ is across a resistance of 2 ohms here. PQ. So what do I do now? I do V equals to IR because I'm trying to find the potential difference. So I'm trying to find V. So if I want to do V equals to IR, my V is what I want to kirakan. Then my calculation I will be equals to 1.2. My resistance of PQ is actually 2 ohms. So oleh itu, my total voltage here is actually 2.4 volts. So this is the second question of a bit of current series parallel. Okay, but there is a bonus question. Okay, so when this question they ask you, I put a piece of copper wire across box C. Okay guys, let me ask you a question. Now when my current masuk sini, okay, just imagine. Okay, sorry, because the positive is on this side. Okay, so we'll see the current now goes out from the positive side. Okay, now they got two pilihan. So this current can either flow across C or flow across an empty part. Which one do you think the current will flow? Okay, now listen up. If both side got resistors, okay, just imagine like Malaysia. If both road also got toll, which one will you take? So depends okay. But both toll also got people jalan. But if Malaysia, if this road got toll, if this road no need to pay toll, what will happen? Everybody will go and squeeze the tak payah bayar toll one. Correct or not? Because one is need to pay, one is no need to pay, you know. So at the end, when this happens, your C will totally not have any light. So we will actually call this as a short circuit. You have a laluan pintas whereby you have like a shortcut already, so current will flow across here. So this light bulb will not light up anymore. So how will your circuit be then look like right now? Okay, so you're gonna have a donkey as well. You're gonna have a donkey as well. But right now, what you are remaining here is A and B only. Your C already short circuit, so it will not light up. Okay, so your ammeter J and your ammeter K right now. Okay, so now this is what will happen. Okay, now check out your ammeter J. This one ammeter J got one light bulb, ammeter K got two light bulb. Alright, so there is a difference. So kalau now becomes like this already, what will happen to your ammeter reading of L? Oh sorry, it's not J, it's L. L and K. So because now they share only one bulb each, right? Correct. So both sides also got 1 bulb each, right? So we will say that the reading of ammeter L and ammeter K will become the same. Okay, so kalau they ask you why, then obviously because now the effective resistance is the same. EFF is effective resistance. Okay, so this one quite tricky because this one got short circuit one. Okay, for the third question for today, we are going to talk about transistors. Okay, so first one, what is the function of the transistor in diagram 10.1? Okay, so when we talk about function of the transistor, we are actually referring to this transistor in this diagram. So generally, transistor has actually 2 applications. Okay, got 2 uses. One is as a what we call a current amplifier. Okay, current amplifier. The second one is known as automatic switch. Okay, so CA is current amplifier, AS is automatic switch. So if they ask you what is the function of the transistor here, the function of this transistor here is actually to act as an automatic, you can say automatic, or you can also call this as automated switch. Okay, automatic or automated switch. All right. Okay. Now, so they want to ask why this buzzer will sound when there is a fire. Okay, Ken? Now, so what happens here is that you have to know, okay, what is the use of a thermistor? Okay, let's just generally say this. Okay, so we have something called a base here, B. We got something called a C, and we got something called E. The main focus that you have to look here is actually our Mr. B. B for boss. Okay, boss is important. Now, if you want your electric current to flow across the buzzer, you need to have base current, meaning to say, if we say step 1, step 2, step 1 must have current first, baru step 2 can only have current. So means you must have the horizontal base current, then only you have collector current. Okay, but then now the soalan here is, how can we have the base current over here? Good question. So this bottom part is actually what we panggil sebagai base voltage. Alright. Now, so if you want to have base current, you want to have this IB. So the first rule is that you must have a very high VB first. Alright. So we rearrange again. So if this is step 2, this is step 1, this is actually step 0. So you need to have a base voltage. Baru you will have this thing what we call base current, then baru we will have this thing called the IC, which is known as the collector current. Okay, but then how to create this base voltage, high base voltage? Okay, so it will bergantung kepada the situation. For example, okay, now if here we have a thermistor, okay, so how this thermistor is going to work is that when the temperature increases, the resistance will decrease. When you have low resistance, you will have low voltage. Now, of course, kalau you have low temperature, you will have high resistance, then you will have high voltage. Okay, Ken? Alright. Now, so they already tell you now there is a fire, there is a kebakaran. So now, how can we switch on this base voltage? Okay, so kita tengok So of course, first of all, we say when there is fire, we will say that the temperature of the surroundings will increase. So therefore, when your surrounding increase, your resistance of okay, you must say resistance of what? Resistance of the thermistor will decrease. Okay, so when your temperature go up, your resistance go down. Okay, so they terbalik. So you see the first part I write is actually this TR dulu, T up, R down. Okay. So after I talk about this resistance, the next part we're going to talk about is actually this voltage. So then we will say, okay, atas and bawah tak sama. If your top voltage decreases, okay, because these two, right, they function as something known as, okay, if they ask you what is these two, these two function as something what we call as a potential divider. Okay, we call that as a potential divider. Top and bottom tak sama. If top become less voltage, then the bottom become high voltage. So they will always alternate. Okay, so when the resistance of thermistor decreases, then we will say that the potential difference across the thermistor will decrease. Okay, faham not guys? Okay, so they are like together one lah, satu gang punya lah. Okay, can, alright. So temperature affect your resistance, affect your voltage. Okay, then I talk about T, I talk about R, I talk about V already. So T, R, V sudah siap. Now the third thing we have to talk about is what? Then now we have to shift our base voltage. So the last 2 marks for this kind of explanation is actually a combo one. Okay, how to say combo? We will say that, okay, so first of all, then we will say that the base voltage, your base voltage across the R, wait. You just have to say base voltage across transistor lah. Across the transistor will increase. Okay, so when your base voltage will increase now, then what will happen? Then we will say that your base current will increase. Okay, when your base current now increase already, then what happens? Then we will say that your transistor is switched. Now it is switched on. So when your transistor is switched on, then your collector current will flow across the buzzer. Then the buzzer will ring off. Okay, can, alright. So remember, the keyword that the steps that you have to follow here is temperature affect your resistance first. Then your resistance affect dia punya voltage. So your steps will be TRV. Then the next 2 marks punya combo is base voltage affect base current switch on transistor, then collector current will flow. Alright, so this is a very simple 4 marks. Guys, this is the year of 2024. I think transistor is going to be very important in your SPM as well. Alright, okay, once you know this thing, then okay, let's be prepared to do a calculation. Okay, now they give you this calculation. They say that, okay, let me just copy this picture all the way down first, so that it's easier for us to do calculation. Okay, so now this is my image here. Okay, now they tell me if the potential difference across YZ is 0.5. Okay, so now this is 0.5 volt. We know that this is 3 volt. Now we also know that your current goes on the outer side like this. So technically, my thermistor and this resistance, they are actually in series. So if my YZ takes 0.5 volt, my atas sini will take how many volt? Will take 2.5 volt. Must be fair, right? Bottom 0.5, top 2.5, right? Okay. So here you will see that my XY will be equals to 2.5 volt. If you want to do working, it will be 3. You minus away the 0.5 volt, you get the 2.5 volt. Okay, faham? Now, then what about the current flowing across X to Z? Okay, what's the current flowing across X to Z? Okay, now you will realize that the current, okay, flowing through this and the current flowing through this is the same. Okay, now why? Because we will assume that most of the current actually flows on the outer side first. Okay, walaupun yes, we have current go in, but now we will be able to do that. I have the voltage here, I have the resistance here. So your school teacher maybe will show you a very fancy formula, like this one, what EVSV R1 plus R2, then bracket, then multiply by V or something like this one. Okay, but you don't need to use very complicated stuff. Okay, we keep it easy. Now, if you want to find the current, you always look at V equals to IR. The rule is very simple. Kalau you nak cari I, you want to find current, you need to have V, you need to have R. Okay, we see this situation. Here got V, but tada R, don't have R. Here got V, here got R. So which one do we use? We use the bottom one lah. So my voltage here 0.5 volt to be equals to my current, I don't know, but my resistance is 1000. So my I will be equals to 0.5 divided by 1000. So it'll be like 1 times 10 to the power of negative 4 ampere. Okay, boleh? Okay, what about the resistance of the thermistor now? Okay. So now you already got the current. The whole entire current that flows across here is 5 times 10 to the power of negative 4 ampere. Alright, okay. So now we zoom in and we look at here the thermistor because now they want me to find the thermistor. Okay, aku tak ada R, I don't have R. So I want to find V equals to IR. Now if I don't have R, obviously I need to have V, I need to have I to calculate this thing. Okay, do I have the V here? Got 2.5 volt. Okay, then I ask you, do we have the current over here? Got, right, because I told you already, the whole entire stretch come down current the same, right? So my current, I've already calculated it to be this. So this current is going to be 5 times 10 to the power of -4 R, okay? And then after that, you will just be able to calculate your answer to be that resistance will be equivalent to 5,000 ohm, okay? Now, some of the teachers, they will ajar this way, pun boleh. Okay, so mine is always V equals to IR. Some of them, they like to teach ratio. For example, if my resistance increased by 5 times, my voltage increases by 5 times, my resistance pun sepatutnya multiply by 5. Why? Because V equals to IR, your resistance increase 5 times, your voltage pun sepatutnya increase 5 times. So that's why you see, right? They from 0.5 to 2.5 is 5 times. So 1 kilo ohm to 5 kilo ohm is actually 5 times. Okay. So according to my method, I just do V equals to IR. But if you use another method, you have to use the very fancy formula, upper R1, R2, R2 bracket with V, that kind of thing. Which is one I find it hard to understand, okay? Or you boleh gunakan the ratio method also okay, alright? So that is on our transistor punya calculation. One last question on transistor. So this is something that you want it to be lit at night and turn off itself during the day. Okay, so out of all this circuit, which one should we choose? So now, if we see here, the obvious choice is going to the one with the electromagnetic relay. Okay, kenapa we want electromagnetic relay? Okay, because very simple, you see that they tell you that here. They tell you that the light has to light up with 240 volt. Kalau you want 240 volt, you need to have the bekalan, the voltage supply of the 240 volt. Meaning to say that my voltage X is already, my liquid circuit X is already tak boleh sudah lah, okay? Then what else here that we have to check for is actually you want your bulb to be series or parallel. So kalau series, that is no good, right? Correct. So now we're only left with W and Y. So which one is it will switch on at night but turn off itself during the day? Okay, so out of the remaining ini tak boleh, between W and Y, we will always choose Y because now this is the position of the LDR which is located at the bottom. Okay, why bottom better? Now, do you remember just now we talked about TRV in our previous question? So when your temperature increases, your resistance decreases, your voltage decreases. So TR is opposite, tapi RV is sama geng punya. R down, V down. T up, R down. Okay, TR is the balik, V and R is always together. Okay, now we want to switch on the light at night. So let's check and see at night can light up or not. So at night, the neighboring light intensity is always low. So I will have high resistance. So when I have high resistance, here I will have high voltage. Okay, now, what is the name given to the voltage at the bottom part? So yeah, just now we talked about this part. This is going to be known as my base voltage. Remember, just now the thermistor is on top. So base voltage at the bottom. Now your LDR, your light dependent resistor at the bottom. But yes, your base voltage is still at the bottom part, alright? So when the bottom voltage increases, your base voltage increases. So remember, higher base voltage, higher base current. Lower base voltage, lower base current. These two always together. So if you have higher base voltage, if you remember our picture just now, okay, you will realize that this now will cause more of my base current to flow. So base current now flow already, okay, because this is step 0, this is step 1. So after got base current, then my collector current will flow. So this will become an electromagnet. Then my switch will tutup. This thing will be a complete circuit. Then my light bulb will be lighted up. So oleh itu, my pilihan di sini is actually circuit Y. Okay, Ken, alright. So what are the 4 examples that, what are the 4 differences here? So obviously, one is the position of the LDR. One is the usage of this electromagnetic relay. with the relay switch. And then after that, the arrangement of the light bulb, and one of the very small tiny detail is the arrangement of your battery side. Okay, so now let's see. Okay, okay, so let's just write this essay together. So the first one we are going to say is your LDR is located at base terminal. At the bottom part. Why? Because I told you base is at the bottom part, so it will be located at the base terminal. Alright, or we will say, we call it also the base circuit. So what is the advantage of this thing? So we can say that at night, you can say that when your light decreases, resistance across the light dependent resistor will increase. So therefore base voltage increases, causing your base current to increase. Then my transistor macam mana? Switch on. Okay, then of course if you want to, you can also say, so therefore then my collector circuit, my collector current will flow and so on lah. Alright, okay. Now then number 2, what's the number 2 one? Is the connection of the battery. So your battery, right, your positive terminal must always be connected to the collector, because that's where you want your current to flow. Alright, so it's a bit of terms, guys. So you can say that the positive terminal of battery is connected to the collector circuit. Okay, you can say collector circuit ke pun you can also call collector terminal. Meaning to say that when you sambung your thermistor, okay, this is your thermistor, right? Okay, so thermistor is always like this one, right? This is collector, this is base, this is emitter. So this is your diagram. You realize that your current has to go from collector here. So that's why your battery positive must be placed on that side. Okay, so why? How can you explain this thing? Now this explanation is the biggest problem, because we then have to say that so that your current can flow, right? But can flow, we cannot just say can flow. We can say so that the current can flow in forward biased. Okay, that is your explanation. What is this forward bias? This one, right? If you really want to know this, you have to relate back to our diode. So make sure you go and read back your semiconductor diode if you really want to know what is forward bias. And then what about the third one and the fourth one? Okay, so my spotlight circuit. So why? So that you must say that your circuit must be parallel. So why parallel? Because they tell you, right, that all the 3 spotlight must receive 240 volt. If you connect this thing in series, they will share the voltage. Parallel means everybody will receive 240 volts. So here, your circuit has to be parallel so that all of the lamps or all the circuit, can receive 240 volts. Or you can say equal 240 volts. Macam tu. Okay, they must be connected in parallel. Okay, Ken? And then last but not least, why a relay switch? Okay. Now, so the answer is obviously here is with relay switch. Now, why do we want relay switch? So that you can switch on, alright, so you can switch on a secondary circuit that has or that uses that has higher voltage. Okay, so oleh itu my answer here will be circuit Y. Then you have to write your explanation, which I think you know here. Okay, I think, right, most of you if you really got study, I think you will be able to choose your characteristics properly. But the biggest challenge in transistor is how to provide an explanation that your teacher will be satisfied. Itulah masalahnya. Okay, like for example, this one quite tricky. I think this one also quite tricky. What is the answer that your teacher will accept? Alright. So now I put one more bonus question here, alright? So this is actually a fire alarm circuit. So you can feel free to do this question, alright? In this notes, you will see that the answer will be provided at the bottom part, alright? So you will see that the answer will be provided at the bottom part, so you can compare your answer. So that's all for the transistor. Remember your calculation, your explanation. So it's a short section for transistor, alright? That will be our next question. We will talk about gravity.